All right, coming to you live from KubeCon here in Atlanta, Georgia, and I'm here with Andrew Godwin. Andrew, how are you?
I'm doing well, very well. Thank you, Barton. It's a pleasure to be here.
Well, I'm glad that you're here, and you're glad to be here. So it
Absolutely.
works out. So Lambda,
hmm
Lambda Inc., Lambda AI. What did you guys used to do, and what are you doing now?
So Lambda's a very fascinating story, right? So 10 years ago, the company was founded, and I was not around at this time to be very clear. But it was founded as a machine learning company doing image style transfer. So I'm sure many people remember some of the original image style transfer papers from back in the day. You would take an existing photo, say, make it like a Picasso, and doing that kind of stuff. And the founders sort of, embarked on this journey, found that building their own hardware was essentially much cheaper than trying to buy it off other people, and started building their own hardware. And from all the stories I've heard, that became the big part of the business. And so Lambda became a hardware company, initially doing sales of sort of desktops and workstations, and then moving on to colo. And then about 3 or 4 years ago now, we started our cloud business. And then obviously in the years since, the cloud business has become a massive part of the company. We actually sunsetted the hardware side of the company well, I think earlier this year. Which is one of the things we're like, all of us are sad about it, but focusing on the cloud is the big
Right.
thing for us now. And so it's now uh, basically all the cloud business, starting from bare data center and building up and building, all what we call AI factories, right? That's the industry term these days.
So right, with the AI factories, you could be considered a neo cloud,
Yeah.
and you had the GPUs before this, right? Is that correct?
Yes, I mean, so the company's always been using GPUs for machine learning research, right? And of the many neo clouds, I think we are relatively unique in terms of coming from a machine learning background purely and sort of growing out of that side of it. But yeah, like Lambda has always been GPU oriented, and initially we started off using desktop and consumer GPUs in machines. Obviously, as we got bigger, we switched to the more commercial offerings, but it's always been very GPU focused. That's kind of been the company from the beginning.
And so, how big is your where you say when you first had your own, and then now that you're letting it out to others, how big are your data centers? What is your future growth plans to the extent that you can talk about it, and margins and revenue? No, you don't have to tell me
Yeah.
about those two.
So numbers are not a thing I can talk about easily,
Right.
as I'm sure you can understand. I can say we have a lot, right? We have
Right.
we have a lot of different regions. Like I think we may be at 15 different DCs across the US
Oh,
now,
wow.
to give you a rough scale, right? It's about as far as I can go. Building out plenty more every year. We have two here in Atlanta, in fact. The
Okay.
local DC team and us are having dinner tomorrow. It's great to see them. They do amazing work keeping everything running. Um,
So when you say Atlanta, because usually what I've heard, these places are out in farmlands, et
Indeed,
cetera. I
yes.
can't imagine real estate here is pretty expensive. I assume it's outside of Atlanta.
It's certainly not in downtown. Absolutely, we're not there yet. No, so we like a lot of places name after the airport code,
Hmm.
and so obviously it is further out in Atlanta where there is more space and you can build industrial sort of buildings, but it's still Atlanta area, and so
Okay.
we name it Atlanta.
So you have any in New York City?
Not yet. I hear Manhattan is a famously cheap place to build real estate, though. So
Exactly. That's the place, Upper East Side, Upper West Side, whatever you want. So right now, what would you say is the profile of the customers that you serve? How varied are they, and is there a specific area that you're focusing on, or a specific customer size or type or industry?
I think, look, one of the reasons I joined Lambda in the first place was the broad appeal, right? So everyone down to like the individual researcher who wants just maybe one or two GPUs for like 24 hours. Like we have a product that does that, all the way through to like maybe you're one of the top 5 AI companies in the world right now, and you need an entire DC building. We'll do that as well, right? And so we serve everyone, and that's kind of the pitch, right? Is that we try and scale up and down. Our focus in terms of growth right now is obviously on the super intelligence market, that's sort of that top end of the market where those big companies, many of the
Hmm.
names. We have quite a few, some of those companies as amazing customers as well. But a lot of the dev team, especially, like there's an empathy there. We want to make sure we still keep the small end of the market as well, right? So making sure that like the individual developer, the small research team, the academic course can still go and rent like maybe a machine, maybe a GPU inside a machine, maybe a small cluster, for the amount of time they needed to, and just trying to have all those pieces sort of served from the same cloth. Because again, we buy a lot of GPUs. Unsurprisingly, as everyone knows, they're expensive.
Yes, they
We're
are.
getting to make sure,
If you
like,
can get your hands on it.
well, we fortunately we can,
Yeah.
right? And so you want to make sure that there is a user for those GPUs at every point in their many year life cycle. And so part of that is making sure that you appeal to every single different customer in that life cycle. We have GPUs that are 7 years old that are still in service and making money because there's still demand for them, right? That's some of the ways it works.
So are people using your facilities for training runs? Anybody using it for inference? And how, when someone does, I was just reading an article about this and the different uh, lengths of the training runs. You can have some that are a couple days, you can have some that go on for weeks. So how does that work with what you all are offering and what you're supplying?
Yeah, the customers are a split, obviously. I think earlier in time, like, I joined Lambda 2 years ago. Back then, training was far more the majority of our traffic, as it was for, I think, a lot of people in our space. These days, it's balanced out much more. And so training runs and what we call inference, right, running the models, I find them really fascinating as an engineer because they are very different in terms of what they demand from their hardware, right?
Mhm.
A training run, as you mentioned, it can be a few hours, it can be a few weeks, right? And often, so as you train, you load all the data in across the entire cluster, and the training just goes basically through just iterations of training and refining the weights, and you get through every so often you checkpoint. And there's some two fun things here, which is, first of all, obviously, when you're training any reasonable size model, you're across more than one machine. They're having to coordinate with each other. The GPUs are doing essentially direct memory access across the network, a phrase that terrified me when I first learned about it, but I've
Mhm.
come to love. And so we're talking sort of microsecond latencies here matter, right? And
Mhm.
so we tune a lot of what we call our compute fabric, in order to make those latencies as close to the line as possible, right? Like the length of the cable matters in some of these
Yeah.
installations, right? Like our DC techs are like measuring and making sure the cables are perfect. There's also the checkpointing I mentioned. So as you checkpoint, basically you take all the VRAM, all the state in all those GPUs, and you flush it to disk. And so that's going to impact your storage array as an absolute ton of data floods all at once, the worst possible case of most storage systems,
Mhm.
into roughly the same place. And so that's kind of the training load. And obviously we designed for that. It's one of the hardest ones. And one of the key problems is if you lose a GPU during a training run, you lose the fraction of the model on that GPU. And generally that's impossible to recover from in most cases. So you have to basically take the job, pause it, roll back to the checkpoint, load it out of disk, and start again. And so there's a whole balance there of checkpointing is a bit slower than you'd like, but you want to make sure you can roll back. So there's a fun balance there. We try and make sure our storage is up to task. We consult with our customers. There's a fun trade-off, right? But that's the training side. The inference side is a bit more like traditional web software, like a bit more I've been doing for the last 20 years. You generally load the models into, it used to be a machine, now it can be a sort of small cluster of machines, but each one is pretty stateless. You send it the context, you send it the prompt, it runs through its set of iterations and layers, your results and tokens come out the other end, but there's generally not a shared state that's important. You have caching that makes things faster, you have a number of other things, but you can treat it much more like a distributed system, like one where like if you lose a few machines, that's fine, you've lost like 1% of capacity. And so in that case, your in-band and network internet connection is much more important. You've got real-time latency to people. So it's a fun balance of challenges, right? And we have to try and engineer for both of them. And it's a really fun push pull, right? Like it's an enjoyable engineering trade-off tension in many ways.
So how would it work when if you're training, you do big training runs,
Hmm.
and I assume then you come back every so often to train on more,
Absolutely.
and then compared to the inference, which I would think that people are using, say, daily, so on a much more constant basis as opposed to a run, which is then finished and then you come back.
Exactly, yeah. So like generally a training run, and you'll have other orchestrators on top of the cluster. So obviously we're at KubeCon, we do a lot of Kubernetes at Lambda. We run the cloud on Kubernetes, we run Kubernetes on the cloud in a wonderful sort of like snaking in its tail way. Kubernetes, you can do the stuff inside there as well. There are other options on top of it that make this easier, but generally, as a model training team, you will be, as you mentioned, like training a model. You'll get to a certain checkpoint in. You say basically a number of iterations in. You set the marker, and then you bring it out and test it, and you have continuous stats on training. But you'll try and use the cluster as much as you can. So like we'll find often our customers will nearly always set up training jobs before the weekend, so they can basically go on, enjoy the weekend, come back on Monday, see the results. But you're trying to optimize cluster usage, but there's always going to be gaps, right? Whereas inference is much more continuous. It does depend on the application. So obviously inference is a very broad church. The one we all think of probably is the chat GPT or Claude style of like you type a question, the token stream to you in real time. Obviously that requires pretty 24/7 usage. It varies a little bit with public holidays and the morning night cycle, other factors. But like it's pretty constant usage, just scaling up and down based on traffic.
So would these be enterprises who are using it?
Yeah, I mean, most of our customers are enterprises, right? And or small companies, right? Like we have a few really exciting AI startups on us as well, where like they've got a brand new model or a brand new fine tune, or maybe even a good wrapping around a model. They've got some good tool usage in there, and they're using Lambda as the back of their compute. But the key thing is we're providing the compute, and then our customers are doing a lot of the work on top of that, right? They're trying to make sure they can figure out, okay, here's how we're going to route tokens in and route tokens out and do all that kind of business.
So the balance between inference and training, do you have to reconfigure systems that you're using, or how does that work as you go back and forth? Are they interchangeable?
It's in part, yes. You should do some reconfiguration, and it's one of the things we try and sort of like help our customers through the journey with, right? Is let's say you're a team who's just done training for a long time, you'll be used to how to set up clusters for training. It's a thing you'll got much more used to. Inference is a little bit different. Like on the storage side, as I mentioned, storage is very different. You're loading models off disk in a much more distributed fashion. And the speed you load the model into VRAM matters. You try and distribute it across the network and a bunch of other things. But yes, it is a bit of a different approach. On the very basic level we operate at, the infrastructure doesn't change too much.
Mhm.
We basically just try and over provision in networking storage so it matches both use cases. It's more how the customer interacts, right? Let's say you're running a Kubernetes cluster, how you're going to set up that cluster and the primitives you have on it would be very different, right? Inference, you're having much more of a traditional load balancer, network routing situation, whereas with training, you're probably going to start thinking about like making sure all the InfiniBand and distributed bits talk to each other. And it's much more stateful as well. It's not quite as throw away and forget as a deployment, for example, might be.
So would the customers who use it for training use it in blocks, then go away, and then the inference customers would be using it on a continual basis? In other words, they have access to resources whenever they need it, whereas training, they come in, they do their work, and they're done, and maybe they'll come back later, but it's a discrete operation.
Yeah, so training generally, you're going to go in knowing how much time you need. So that we have a product called one-click cluster, which is essentially you pick a slice of one of our much bigger clusters. We'll partition it off and sell it to you for a range from several weeks to several months, maybe several years if you'd like, right? But crucially, usually come in with like an idea of like what your bounds are. It's usually for training. You can use it for inference. Inference is a bit different. So the larger you get, the more the averages play in your favor, and the more the base load approaches your peak load, right? I've worked in several different industries across computing. There are places we would love to have had this be the case, but like what we've seen from inference is you can get pretty close to a good base load, certainly. And so, yes, you can scale up and down. The secret of a lot of cloud computing, which we all know, is that someone is left holding the cost of having a GPU always available.
Right.
A lot of the time, we get customers who come and ask us, we would love to be able to sort of reserve the option to spin up 1,000 GPUs at any time. It's like, I would love that too, but it costs money in terms of capital expenditures, in terms of operational expenditures to keep those GPUs in a DC, powered and cooled. And so a lot of it is generally we find that buying a lot more fixed capacity is much more cost efficient for most customers. If you can have a good baseload prediction, obviously you're going to burst as well. But often you're going to come in with a pretty good idea of what your baseload is as well. And so generally we'll see like customers come in buying, because if you're a big customer, you want maybe a multi-year contract. At that point, you're talking to our sales team. You're talking in more fixed terms, right? So that's often the way it works.
So you mentioned data, you mentioned storage.
Mm-hmm.
If you don't have a data strategy, you don't have an AI strategy, I have heard said. So how do you all keep your storage and your data architecture up to date, and both latest equipment and latest ways of architecting it?
Yeah, so we have an amazing storage team, first of all, internally. They are the experts on this stuff. I'm the general architect. I do not know all the specifics. That's their job, right? And so them and some of our hardware folks are really plugged into the needs of this industry. We have a number of great vendors we work with as well in terms of storage appliances. We also do some of our own research into storage and doing sort of different distributed file systems, things like that. So like, it's always trying to stay one step ahead of the game, and especially it's not just speed or availability, it's also security, right? You need to have like encryption at rest is obviously a huge ask for a lot of customers. And so a lot of it is just trying to make sure you have like the middle ground of all these things. And then even then you've got the balance between, so a lot of machine learning uses NFS, or what we call read write many, right, in Kubernetes, as its main backing store, which is, as we all know, the hardest one to make highly available and consistent. And so it's a case of like, okay, everyone expects this. If you've got researchers, they want home directories that are persistent across clusters. And so honestly, like it's very dependent. Our biggest customers, we will go in, we will talk to them in sort of the sales process about like, what are you doing? Like, how are you going to use this? And we try and tailor the hardware to them so that if they're going to have like, for example, a massive training job, we'll make sure we have, a cluster size to handle that. If they're going to have separate home directories, we'll make sure that that's arranged. But like it really is dependent on the cluster. Like at the scale we're doing at this point, a lot of it is like, hey, what are you going to use this for? Let's like tweak it a little bit, that last 5%, to make sure it matches what you're doing.
So speaking of that, capacity, how do you plan for all this to capacity? Because there's how much energy do we need? How much data space do we need? How many chips do we need? How many customers do we need? How do you figure that out? Do you use AI to figure this out?
We use a far more valuable resource, which is our data center infrastructure and planning team.
There you go.
So I have to give a shout out to Ken. Ken is an incredible head of all that whole part of Lambda. But there's a whole group of people who just go around the country and the world trying to basically find power and space to put this stuff in. Like it's no secret that power is the scarce resource these days in data centers, to the point where we've taken some space in existing DCs that were built a bit before the AI boom happened, and they provisioned what they thought was that right ratio of space to power. But of course, our racks are incredibly dense. The liquid cooled one's doubly so. And so you have this giant data hall, and maybe like a third of it has racks in it because that's the power density's been hit way before the physical density's been hit in the data hall. So yeah, like planning is a huge part of the deal. We have an incredible team doing it. I wish I knew more about it. I get to hang out with them very occasionally. I would love to have a bit more, right? But like they're out there basically trying to find power, trying to find good internet connectivity, and physical space, and all three of them combined. And basically, like they're out there doing that. Our job as engineering is like once they find the space, once they get it ready, we try and step in and get stuff going in there, right? That's kind of how the whole thing rolls off.
And then from the macro level, when you're going to hit a diminishing returns for training, and people all of a sudden aren't going to need the training capacity that they did need? When are we switching from large language models to smaller, more compact ones? So many variables out there. Do you have any, in general, your thoughts of how things might go with regards to the amount of training and the amount of the size of language models, et cetera?
Yeah,
One man's view.
look, if I knew this for reality, I'd probably be a billionaire in a few years,
Yes.
right? And I've heard for many years now, oh, we're at the plateau. And sometimes I think we're at the plateau. And so far, we never have actually been at the plateau, right? I think the previous plateau we kind of reached, but then mixture of experts, I think, gave a big sort of like shot of epinephrine basically into the industry's leg.
Or terror.
Or oh no, but it's like it was a big like massive step improvement. And again, you get much high quality out of the models. I expect there's more of that coming. And also, I do want to highlight, right, that I've been doing machine learning on and off for about 20 years. When I started, it was, what kind of flower is this, right? It was very simplistic stuff. But even inference is about more than just language models, right? So we're seeing language models now. I think there's still personally a lot of frontier in understanding images, in understanding audio, in having a lot of like fusion and synthesis of those inputs, and then also a synthesis of outputs, right? If you think about how humans interact and communicate, it's not just written text. And in fact, I'd argue in some ways written text is maybe one of the worst ways of doing it in terms of how humans in day-to-day life interact. It's just the one that the training data is most readily available for, right? We've got an absolute massive corpus of training data. I think the data size is one of the huge accomplishments of what's made LLMs get as far as they have. But in many ways, like I just don't know. I expect we're going to see, I think, a bit more of a shift to inference. I think there's some really interesting innovation on the inference side, and tool usage, and even like fact correcting and grounding models and their outputs, right? There's a lot of things you can do with model outputs we're not doing yet. But I think training is also not going to vanish. I suspect we're going to have some very interesting leads in training for a long, long time as well.
Yeah, I was reading, and it was DeepSeek has got, is it OCI? What is the, now it's turning to optical data that it's sucking up.
Yes.
And how does that affect things going forward? Because there's lots of that out there.
There is, and the problem always, as with all machine learning, is quality of input, right? Like labeling was always the
Mm.
thing that we always found. Even 20 years ago, labeling your data, having quality feature extraction was always the problem. I think that still remains. But one of the fun things now is you can use the current generation of models to feature extract for the new generation of models in a really interesting way. And so I think there's a lot there that can be done. But yeah, it's a very interesting space, right? And obviously there's a huge number of like copyright and IP problems just bubbling under the surface of all of this, right? And that is not a topic I'm going to branch into. Like it's a very complex one. The bridge between learning from others and also reusing people's things and make money off of is a very difficult line, right? To draw a line under. But I do think there is going to be a bit more innovation there in terms of like taking that data input, having it more labeled, and then the golden apple, I think, of machine learning is a model that can train itself more, that has a high enough quality that you aren't going to have loss in its outputs to feedback its inputs. We've not got there yet, but I think there's going to be an interesting step towards having that sort of fully synthetic training data at some point soon. And I'm very curious if it ends up going down kind of a dead end training path. Like overfitting is a classic machine learning problem, right? We've all seen it. I think some of the models today overfit, honestly. I have some critiques on those. Or does it go part down the realm of having too much entropy and just sort of going off kilter a little bit? Maybe there's a fine line to steer into. I think that's just one of the difficulties for the industry is like, how do we have all this data and try and steer it in some ways replicate the more organic experience of an organism that can start training itself and learning concepts by itself, right? Inside machine learning models, they don't think in words, they think in concepts. If you look in the set of weights, you can often pick out. I mean, Anthropic particularly have done some good research on this. They've got some good papers. Of like, they can occasionally pick out specific like weights or essentially neurons, think of it as a neural network, that mean a concept. So they already do kind of think in concepts in a weird way, obviously rooted in language, and crucially often in the English language, which I think, as a speaker of the English language, I have my problems with choosing that as the route. There's maybe better options than that. I'm sure there are some Esperanto people out there who are like, perfect constructed
Of
languages.
course.
But it's just, I think there's a really interesting set of research there. And like, can we get that synthesis going? And honestly, then stop having to go off the created works of humanity and have these things start making their own path a bit as well.
Oh, brave new world. You heard it here first. Andrew Godwin, thank you so much.
Thank you very much.